All right, so in Chapter 6 and Chapter 7, we're going to start talking about inferential statistics. And all that really means is we're going to take what happens in a sample and use it to draw conclusions about the population. So this is where we really start to kind of apply those descriptive statistics that we learned back in Chapter 2. In Chapter 6, this is all going to be about constructing confidence intervals. And confidence intervals are simply tools that we use to estimate a population parameter. All right, and in this case, we're going to focus on estimating the value of mu, which of course we know is our population mean. Now, some terms that you should be familiar with. Every confidence interval will have a specified level of confidence, and you can see right down here that is just the probability that the interval actually contains the true value of mu. So we want that to be high. We want there to be a good chance that our interval correctly estimates mu. That's why you're typically going to see these values of 90, 95, and 99%. Another term that you should be familiar with is what we call the margin of error. And this is just the value that we use to determine how much room for error we should allow on either side of the sample mean, which is of course that value of x bar. So you can start to see at this point why your notation is really going to come back into play. You've got to be clear on the difference between x bar and mu and any other sample statistics versus population parameters. So that's what we're going to start with, is kind of a review of the notation that we've seen up to this point. All right, so we should be very familiar with mu because we talked about it a great deal in Chapter 5. And we know that mu represents the mean of the population. That's what we're going to be trying to estimate with these confidence intervals. And what we're going to use to do that is a value of x bar, which we know represents the mean as well, but from a sample data set. Now, some other values that are going to be very important to us as we do this will be the value of n, which is, of course, the size of our sample, and the standard deviation. Because we're going to be using an interval estimate, the amount of variation is going to be very important in determining how big or how small that interval needs to be. So we're going to see values of sigma, which again we saw this a great deal in Chapter 5. So we should know that sigma is always our population standard deviation. And S, we haven't seen that one in a little while, not since Chapter 2, but S also represents a standard deviation. But this is for the sample data set, which is a subset of our population. All right, now, the reason Chapter 6 breaks these confidence intervals up between 6.1 and 6.2 is because we're going to talk about what's called a z-interval, and then we're going to talk about what's called a t-interval. So you'll notice here, in 6.1, we're going to focus on the z-interval. Z just means we're going to be using standard normal values. And the way that you know when you need to use the z-interval is when you have the value of sigma, right? And of course, sigma we said down here. This means we know the value of the population standard deviation. Now we're going to have a couple other things to verify as well. But the thing that will distinguish between the z-interval and the t-interval is whether we have that population standard deviation. So when we start to analyze a data set, the first thing we're going to do is write down everything that we know, like we always have. So we're going to look for a value of x bar, a sample mean. We're going to look at our standard deviation, which will either be a value of sigma or a value of s. And then we're going to use that to calculate what we call a margin of error. And that margin of error will be allowed on either side of the sample mean. That's the basic format for constructing a confidence interval. Now, I'm not going to have you doing the margin of error by hand. We're going to use technology here, but it's going to be very important that you make sure that you're looking at a case where you're able to use the z-interval. So first example, right? I said the first thing you want to do is write down all your information and make sure that you're able to use the z-interval. And that's what I'm going to do. So I have a random sample of 60 refrigerators. All right, so my sample size n is equal to 60. I'm given a mean. Notice this is the mean for the sample. So that is a value of x bar. Mean repair cost is $150, again, just for the sample. And then notice I'm given a population standard deviation. Population standard deviation is a value of sigma. And that is how I know, right there, that I'm going to construct a z-interval to estimate the population mean. Now again, there were a couple of other conditions that we needed to verify, and we'll do that too. So we will make sure that we have a random sample and a sample size of 30 or more. And both of those are met here, right? Random sample, sample size was 60, well over 30. So we'll verify those, but again, the thing that really distinguishes between Z and T, which we'll talk about in the next section, is do you have the value of sigma? All right, now once I determine that, I'm going to go to StatCrunch. All right, I'm going to let it do the calculations here. So in StatCrunch, I'm going to go under Stat. And don't worry about the data set I have in here, right? We're just going to access the menu from the Stat menu. And because this is a z-interval, we're going to go under Z-Stats. Now, under Z-Stats, we're going to choose one sample. It'll always be one sample. And because we have summary statistics here, we're going to go to with summary. And that's just going to bring up a little dialog box for me, where all I have to do is input the information that I was given. All right, so again, that is my stat menu. I went under Z-Stats because it was a z-interval. I did one sample. And because we were looking at summary statistics like N and X bar, I went to with summary. All right, now I'm just going to input my information, and I've written everything down already. So I have a sample mean of 150. I have a population standard deviation of 15.50. All right, I'm just pulling that from my problem, and I have a sample size N that is equal to 60. Now, you'll notice when you look at your dialog box, it defaults to a hypothesis test. That's something we're going to talk about in Chapter 7. So you need to make sure that you come down here where it says confidence interval, and you click that little button. And when you do that, it's going to ask you for a level of confidence. Remember, that's that probability. And that is something that will always be given within the problem. So we need this interval to be 99% accurate. So right here, we're going to put in a level of confidence in decimal form of 0.99. All right, and that's all I need to do. Just input my information and hit compute. All right, and when I do that, what I'm going to see on the far right-hand side will be a lower limit and an upper limit. This is your interval that estimates the population mean. So I'm going to round these to 2 decimal places. My lower limit will be 144.85. So I'm going to input that here. And I'm going to write this as an interval, so I'm going to put it in parentheses. That's my lower limit. And then my upper limit, go back. clicked away from my screen here. So let me bring that back up. Just inputting all that information again. There we go. So my lower limit was 144.85. My upper limit is 155.15. All right, now again, what you want to remember is that this is an estimate for the mean of the entire population for the value of mu. And this estimate is done with a 99% level of confidence. I'm just abbreviating that. This was a 99% confidence interval. So what we've done right here is exactly that. We have estimated the population mean with a probability of 99%, and we're stating that that population mean falls somewhere between $144.85 and $155.15. So just to clarify, as far as the interpretation goes, this 150 was the mean, but only for 60 refrigerators. This interval right here is estimating that mean repair cost, but this is estimating it for all refrigerators because it estimates for the full population. And that's what these intervals are always going to do. All right, now sometimes you will be asked to do this based on data, and you can do that using StatCrunch as well. So what I'm going to do in a case like this, first thing, is I'm going to take my data values, in this case stock prices, and I'm going to store those in StatCrunch. So I've got the stock prices from this data set all entered here in column 1, and you know from StatCrunch you'll be able to just load those values right in. Now again, before I do anything as far as intervals go in StatCrunch, I'm going to make sure that the Z interval is the proper one for me to use. And remember, that comes down to, do we know the population standard deviation, which is a value of sigma? Because we do here, that's how we know that we're going to use Z. Now again, we'll verify the other conditions. It is a random sample, and we do have a sample size of 30 or more. Okay, but again, largely comes down to, do you know that population standard deviation? Now, when I go to construct the interval here, I'm going to go back to the same place, which was stat, Z stats, one sample, but then instead of choosing with summary, since I have the actual data values, in this case, I'm going to choose with data because I have the actual sample values here. All right, so again, I've got my data set listed there. I go to Stat, go right back to Z Stats, but this time I choose with data. So now it's going to ask me, okay, where have you placed your data? I'm going to choose variable 1, or in this case, I've got my actual values labeled there as stock prices. I do have to put in the standard deviation. It says optional, but it's really not for Z, because if you don't put it in, it's going to calculate from the sample, and we don't want that. So I'm going to put in sigma at 2.62, and then once again, I'm going to select the confidence interval. Now I'm actually asked for 2 intervals here, so we're going to look at the first one, which is a 90% confidence interval. So just like I did before, I'm going to click that little button next to confidence interval, and I'm going to put in a 90% level of confidence. And again, I don't need to worry about anything else on this screen. Just where's the data, what's the standard deviation, and confidence interval with level of confidence. I click compute. Once again, I'm looking for the interval, so I want lower limit and upper limit. Once again, I'm gonna round these to 2 decimal places. My stat lab will tell you how to round. So I've got a lower limit of 19.22. And I've got an upper limit of, if I round that, 20.70. So again, the interpretation here, we could calculate the mean for the values in this data set up here. That would be a value of X bar, but it would be the mean price only for that sample data set. And if you look back at your StatCrunch output, it actually tells you that. Sample mean is 19.96. That's the mean for just these values in our sample. All right, just the values right in here. The confidence interval, once again, remember it is an estimate for the population mean mu. So X bar, the sample mean, would tell us about just the values in this sample. This interval would tell us about the mean price for all closing stock prices, not just a sample, but for all of them. And this interval says there's a 90% chance that it'll fall somewhere between $19.22 and $20.70. All right, now I'm going to let you go back and finish this out. You were also asked for a 99% interval, so you'll need to go back and change that level of confidence. And when you do that, compare the widths. Look at what happens to the size of that interval when you go from 90 to 99%. Now, what I want you to do at this point, pause your video, because I want you to go ahead and work the problems in 6.1. All right, get comfortable with using StatCrunch, looking at the Z interval. Work through those problems in 6.1, at least the practice, and make sure you're comfortable with that. Because what we're going to do in 6.2 is we're going to look at something called a T interval. All right, so again, if you haven't, pause the video, do your 6.1 work, and then once you've done that, we'll come back, we'll look at the T interval, and this is going to be used when you do not know the population standard deviation. Okay, so again, remember that sigma is the population standard deviation. And this is what we're looking at here. What do we do if that value of sigma is not known? Now, we're going to be using something called the t-distribution. We'll talk about it more specifically in Chapter 7. All you really need to know about it right now, it's another bell-shaped curve. This says the tails are thicker, but an easier way to look at that is essentially it's wider than the basic standard normal curve. So it's going to give us wider intervals, basically because we don't have as much information, because we don't have that population standard deviation. You should notice these other two properties are the same, so those are always just extra things to check. But what is the difference between using Z and using T is, do you know the value of sigma? So let's look at our first example where we don't have that information. So just like I would always do, I'm going to start by writing down everything I know. So I have a random sample of 5 people. Notice again, I've got a mean, but it's the mean for the sample. That's a value of X bar at 22.2 miles. And then notice here, we've got a standard deviation, but it only applies to the sample. It's not for the whole population. To be sigma, it has to be for the whole population. So that means in this case, I have a value of S, sample standard deviation, and it's 5.8. All right, now that's going to be very, very important that you can distinguish between sigma and S, population versus sample, because when you only have the standard deviation for a sample, that's when you know to use T. Because again, you've got standard deviation, but it's not for the population, so the value of sigma is not known. Now, you saw T-stats when you did this the first time, so you can probably guess here you're going to go back to stat. But this time you're going to choose T-stats. Again, because you don't know sigma. All right, for the rest, you're going to do it the same way. It's a one sample. And in this case, we don't have the data, we have the summary statistics. So you're going to do with summary. All right, so again, when I don't have data, it doesn't matter what's in here. I'm just going to go to stat, but this time I'm going to go to T-stats. All right, I'm done with Z. I'm not using that here. T-stats, one sample, and again, this is done with summary because we have summary statistics. So I'm going to pull the information from my summary. The mean was 22.2. Notice this will kind of remind you it says sample standard deviation. So you know it's not sigma, all right? It's just from the sample. That was 5.8. And then my sample size here was small. It was just 5. Now we've already said this is going to be using a T interval. If you're looking at that sample size and you're saying, wait, that's not a sample size of 30 or more, notice you're still okay because you're given a normal distribution. This is just like 5.4. So just to clarify, that third property says either your sample size is 30 or more, or you are given a normal distribution. So one or the other there, and in this case we're given that normal distribution. Now the other thing I need to pick out here is my level of confidence, just like I did for the Z interval. So we're going to be doing a 95% confidence interval, estimating the population mean. So once again, I'm going to come down here and click confidence interval. The level of confidence is indeed 95%. And when I click compute, once again, I want the interval, the lower limit and the upper limit. I'm going to round to 1 decimal place here. So my lower limit would round to 15.0, and my upper limit would round to 29.4. The interpretation is the same. So as far as, what does this mean? The sample distance was 22.2 miles, but only for these 5 people in the sample. Sample mean. This is estimating that mean distance for all, not just these 5. So the mean distance for all is estimated somewhere between 15 miles and 29.4 miles. And that's calculated based on sample size, based on standard deviation, and based on level of confidence. All right, now you'll notice here just kind of a quick thing to point out. Sometimes you will be asked, what is the margin of error? That does not mean you need to go back to the formula for margin of error. All right, there is a very easy way to kind of figure out this information based on your interval. To get your margin of error, all you need to do is look at the range of your interval right? So 29.4 minus 15, and divide that by 2. Because remember, the margin of error is allowed on each side of the interval. That's why I'm dividing by 2. So we would be looking here, if we subtract out that 15, at a range of 14.4 for the interval. Divide that by 2, and that would tell me this interval has a margin of error at 7.2. And you should also notice that for every interval you construct, the sample mean is always the midpoint of the interval. So that sample mean should always be sitting right at the center of the interval. If it's not, there's something wrong. And so, if you're given an interval and you're asked what is the sample mean, all you have to do is calculate that midpoint, add the limits together and divide by 2, just like we did back in chapter 2, and you can get that sample mean value, if you don't already have it, for the interval as well. Okay, so we're basically, we're doing the same thing. We're still estimating population mean. We're still using the same type thing in StatCrunch. It's just in this case, we're moving to T-Stats because we do not know the population standard deviation. Now, just like with Z, we can also do these intervals based on data. And so that's what we're going to do in our last example here. All right, so I'm given a data set this time, and when I'm given a data set, just like I did before, what I'm going to do first is I'm going to store that data set in StatCrunch. Now I've typed mine into variable 1, those GPAs. You'll be able to load your data set straight in. So I've got that. The second thing I'm going to do, because now I have a choice, is I'm going to make sure that I choose correctly, and this is always the case. Should I use Z or should I use T? And remember, the way you make that decision, you use Z if you know the value of sigma. You use T if you only have the sample standard deviation S. Now, the only way you have sigma is if it is given to you. That's the only way you can have it. If there's been some previous research done and it says here's sigma. If you're calculating it based on data, which is all we have here, then what you're going to have is only a sample standard deviation, which is a value of S. So the first thing I'm going to note here is that I am not given the population standard deviation. Therefore, I'm going to construct a T interval to estimate that population mean. And I'll verify the other properties here. I do have a small sample size, so I'll make sure that I'm given a normal distribution and a random sample. So always checking those conditions first to make sure that you're able to use that particular interval. And then once I know that, I'm going to go back to that stat menu. I'm going to choose T-Stats. It's always going to be one sample for what we're doing. And then again, in this case, we don't have the summary statistics. We have the actual data set sitting right here. So we're going to construct this with data. So I've got my GPAs loaded here. Stat. Again, this is going to be T-Stats, because we don't know the value of sigma. One sample. And I'm going to construct this with data because I've loaded the values. So just like I did for Z, I'm going to tell it this is where I've placed my data. I'm going to select confidence interval. Notice I don't have to put in standard deviation here because I don't know sigma. I go to confidence interval, and then I make sure that I input the proper level of confidence. So I want a 99% confidence interval for the population mean mu. I input my level of confidence. That's all I need to worry about. Click compute. And notice it gives me several pieces of information here. It gives me sample mean. Gives me standard error. That's not the same thing as standard deviation, but it does give me the lower limit and the upper limit for my interval. So I'm going to pull that first. The confidence interval, the lower limit would be rounded 1.56, and the upper limit would be rounded 3.15. All right, now that's the main thing that I wanted here, was an estimate for the population mean. But I was asked for a couple of additional pieces of information here. All right, I was asked for the sample mean. That would be the value of x bar, which would be the center of the interval. And that is something that was given in my interval output. So sample mean is rounded 2.35. All right, that's sample mean. That's the mean GPA, but only for these 15 values, right? Only for the sample. Again, the interpretation here, this interval estimates the GPA for all students, not just these 15. And it's estimating it somewhere between 1.56 and 3.15. Now, I was also asked for the standard deviation here. That's something that's not actually given in my interval output. But remember, you can very easily calculate summary statistics if you need them. Once you've loaded the data set, stat, summary stats, we've done this a bunch, columns, put in variable 1, that's really all you need to do. And notice part of the default calculations are both mean and standard deviation. So I've already got mean, but I could pull it from here as well, 2.35. Standard deviation, move over a couple of spots, and it does default to sample, is 1.03. So depending on, how much information your question asks for, you can pull all of this information from StatCrunch. Again, these are the values just for the sample, just for the 15 students that were given. This interval is what's estimating the mean GPA for all students, not just for that sample. All right, now what you're going to see on this homework, again for 6.2, now that you have a choice, every time you're asked for a confidence interval, you're going to have to make sure that you're choosing correctly. Is it Z or is it T? Always look at your standard deviation to make that choice correctly. And then you're going to use StatCrunch to construct that interval. So the calculations, all right, all the kind of nitty-gritty detailed calculations, you're not going to have to do that. That's going to be in StatCrunch. But you are going to have to make sure that you can choose correctly between Z and T. And in order to do that, you've got to understand, do I have sample standard deviation or do I have population standard deviation? And these same things are going to be important for us in Chapter 7 as well. So the best thing is to get a good strong hold on them now with what we're doing in Chapter 6. All right, so at this point, you want to go in and work on your 6.2 homework, making sure that you understand how to use these things in StatCrunch. If you need additional clarification in StatCrunch, I've done a couple of other things. One, I posted completed notes for you. And in those completed notes, I put screenshots from StatCrunch. So if you need to, kind of go back and just refresh your memory, you can go there. I also posted the StatCrunch video for you. Now in the video, they only do this using the T interval, I think. So you'll just have to remember, it works pretty much the same, but you have to choose between Z and T. All right, and of course we'll talk more about this in class if you have questions, but make sure that you've worked through your homework in 6.1 and 6.2 so that you know if you have questions and so that you are prepared to work some of these in class next time.